Hi guys, this is revision session part 3 of EIS. In this video, we will be taking through chapter number 3. Chapter 3 is a very extensive chapter dealing with 3 parts. Part 1 deals with all the information system components. Part 2 deals with all the information system controls. And part 3 deals with miscellaneous concepts and audit, information system audit. So what we will do in our revision session is also go by 3 parts. Part 1, this is going to be a little extended session only on the information system components. What are the components, how are those components, how they are established, and this entire session is only on the information system components, which is major part of the chapter. Also after this, we will go around discussing in the next video information system controls, and part of the controls and audit we will be discussing in part 3. So let us start with this chapter. First, in this, I would like to introduce you to these two words called as information and system. What is the word information and what is the word system? I think the word system has already been discussed with you. That is a series of small components that are working together, right? If small components are working together, they're working together to achieve common purpose, to achieve a common goal. That's what. So if various components are working together to achieve a common purpose, that's what is called as a system. We have already seen this. Now let's come to this word information. Before talking about this word information, I hope you should know what do you mean by the word data. Data is about raw facts and figures. Data is just raw facts and figures. So if data is just raw facts and figures, then what is information? Which is nothing but a processed form of data. That's what is called as information. But that's a very blanket explanation. If you have to go a little more in detail as to understand what exactly is the word information, it also takes into consideration who is the recipient, what use it has. Anything that is useful only for decision making, that's what becomes information. So simply whatever is existential around us, that's only data. Okay, so taking all that into consideration, we will now proceed further to understand the various components that make up to a information system. In other words, in today's context, when we say what information system is, it is nothing but a data processing device. So if something which is capable of being called as data, that is being processed. So data, when it is processed in a form that is meaningful and understandable to the others, that's when it becomes information. So such activity of converting data into information is called as data processing. What is it called as? It is called as data processing. And such data processing, whatever we do, that should be in terms of how long will it take, what will be given as input, what will be given as output. All these are taken into consideration. So taking all that into consideration, we are simply calling these information systems in today's context as computers, which are now obviously made of hardware, software, which is what I'm going to take you through. So are you clear about this word information, for which we need to know this word data, and then what is the system? So this topic, information systems, is now nothing but a set of or a series of devices that work together to convert data into information. So that is our context of discussion till now. Let us proceed further in trying to understand what are the various components of the information system, the various components of information system, and let's also see how that entire thing works. So I will keep revisiting this place, so you should, as I told you in my first video, if you're making notes of this, it's going to be very helpful for you later. Information system components. Let us have a detailed understanding of this. So keeping it short as a revision video, yet trying to provide you the complete understanding and quality. That's our motto through this. So let's see how that goes in. So information systems, the very first piece here, we're talking about people Who are those people? What will they do about? Then we will discuss about what is called as hardware. Exclusively what constitutes to hardware and what will be the entire discussion around it. Then we have software. Now software is further classified into operating system, or it is called as system software, or simply it is also called as the operating system. What does the operating system do? Different functions are there. We'll catch up about that. And then the other type of software is called as application software. What is application software? What are the types of application software? That also we will see. And the next two components, one is about networks, because that is very essential for connectivity of systems in different places. And then last but the most important thing, data. So this is the broad overview. Right now what you see there is a broad overview of the entire perspective of this concept overall. So what exactly is the concept of information systems? How do they work? All that is something that we are going to see. Let me first quickly introduce about people, because people are the most important element in the entire information system. Without them, all these non-living things are only just bits and pieces of the information, and we don't really want that. What we are actually going to talk about is the set of who are these people, what do they actually do. So there are people are nothing but, in other words, you can call them as human resources. What do you call them as? Human resources. And as part of human resources, we have four types of people, who are people who do run the programs, then program the program and create it. Actually, you can say program the program in the sense creating the program. Run program. We have then two activities, manage and maintain. Then if you go by the ones who do it, the ones who run the program, these are people who are called as end users. The ones who program it are called programmers or coders. Manage and maintain, these people are called administrators, or simply admin. So what is the first and the most important component of information system? It's called people. People are the most important part of the entire information system concepts. So guys, this topic has been touted to be one of the difficult concepts in your book, because a lot of people don't have the orientation towards these, so they find it a little difficult. So I hope today's video is going to give you a clarity and also a perspective about how to go about this, right? Component number one. Now I'm going to component number two, called hardware. Let us extend on this discussion. In hardware, we have different types of hardware. So let me explain you what are all those in greater detail. So exclusively this part of hardware is broken down into, first, input devices. Then we have something called as processing devices. In colloquial language, we also use the word processor or processing chips. So processing devices, input, processing devices. Then we have what is called as memory or storage devices. Memory devices or storage devices. And then we simply have output devices. Nothing much to discuss there. You know these devices as well. So let us talk about input and output devices first, because you know them. Input devices are all devices which are helpful to send data into the computer, wherein text based input is given by keyboard, voice based input is given by mic, and touch screen, touch based input, touch screen, keyboard, mic, scanner, webcam. You have so many devices which are called input devices, or nothing much to discuss in today's generation about what these devices are. And going further, we discuss about what are output devices. You know what output devices are: speakers, printers, the LED monitors, and I'm saying etc. You know what these devices are. Let's not waste around much of a time. Got it. So you go about input devices and output devices. This is about the hardware. What is hardware? Hardware is nothing but the tangible portion. You know what tangible means? That you can touch and see and feel. That is called tangible. So let me first explain you the definition, then we can. So hardware is a tangible portion that you can actually see and touch. That part of the computer which you can see and touch, it is called what? The hardware. It is called the hardware, and that I don't think should be a problem here. That is what it is all about in this. Then we have input devices, output devices. Then let's talk about processing device, or rather you call it as the central processing unit, which you've been seeing from ever you know about computers. You've been hearing this about central processing unit, or in short it's called the CPU, which has 3 units, which is what? 3 units, which is the control unit, which controls the flow into and out of the computer, into and out. What goes into the computer, what comes out of the computer, that's what is the control unit taking care of. And then you obviously know one of the basic units, it is called the ALU, or the arithmetic logic unit, which does addition, subtraction, multiplication, division, greater than, less than. All these activities are taken care by the ALU. Predominantly all the mathematical functions are taken care by the ALU. And then coming to one of the most important memory devices, which are called as registers. Registers are small in size. They are either 32 or 64 bit small memory units. Like you even have them in your calculators for, you know, continuing functions, like what do you say, the M plus function is a kind of a register, basically, because they accumulate memory and the storage units, small storage units with small instructions. Like say, they're called as different types of registers. First one, they're called as accumulators. Accumulators are totally like your M plus function. They accumulate values to keep running totals. Then we have address registers. Address registers are nothing but which store the address of a particular area where a particular content is stored. And then we have small registers which store some immediate content, called as storage registers, and the other type of registers which is called as miscellaneous registers. So different type of registers we have, and they are small, 32 bit or 64 bit in a computer unit. That's what the registers are meant for. Then let's get to the memory. Very important part of memory unit is we have 4 different types of memory, which I will explain in clear understanding now. We have memory devices or data storage. Memory devices are also called as data storage devices. Some of the data storage is permanent, while some of it is not. So first we have what is called as internal memory. We have what is called as internal memory. In internal memory, this registers a part of the internal memory only. Registers. And then we have a temporary memory which stores all the recently accessed places, which is called the cache memory. Pronounced like CASH, but it's called cache memory for all recently accessed main memory locations. Whatever main memory locations you recently accessed, a copy of that gets stored in cache. So that cache memory is a temporary memory, and that's when your system is slowing down. There must be a lot of cache that has been stored, keeping all the recently accessed memories. So whenever your device turns slow, the reason why you eliminate cache or remove cache memory is also that only, so that the device has enough space to do the work again. So internal memory, registers and cache. Then we have what is called as primary memory. Primary memory. We have 2 things in primary memory. One is called a RAM, random access memory. Then we have a read-only memory, RAM and ROM. Every computer program runs on the RAM only. So the higher the RAM capability, the faster will be the processing abilities. Now you know, like you've heard it, 2 GB RAM, 4 GB RAM, 6 GB RAM. RAM is a random access memory. The best thing about RAM is it is volatile. That means once you power off the device, whatever has been stored on RAM will immediately get eliminated. Now That's one of the reasons why when things are going out of your hands, that too much processing is happening and lot of programs are open, suddenly your phone or computer stops to respond. And in our colloquial language, that is only called as hang. Nothing goes and hangs anywhere. It just stops and says, I am not able to respond anymore. That's what it is trying to tell you. Stops responding. And when you stop responding, what is you will immediately become a doctor and do what? Just restart the entire system and bring everything back to normal, and the device starts working normally. You know why? That's only because RAM's memory is volatile, and since the memory is volatile, it erases everything that's there on the RAM temporarily. So it's only a temporary storage. But ROM is not like that. ROM is permanent memory. Now let's say ROM generally stores all the manufacturer's information. Irrespective of which program you use, what you use, RAM generally, it stores the very much useful, like manufacturer's device serial number, manufacturing date, all this permanent content, compilers, interpreters, all the language translators, all those are stored by the primary memory, which is part of the ROM. That is why it's called a read-only memory. You can read it but not edit it. It's not volatile. It is a stable memory. It does not change. So these two memories are very much there within the system, and internal memory and primary memory. Then comes, sometimes what happens is your primary memory is a small capacity. It does not be enough sufficient to store, and not only that, it's volatile, right? So RAM cannot store anything. So for storage purposes, we use something called as secondary memory, which again is a simple memory, because you guys have started using pen drive, CD, DVD, hard disks. All those are called secondary memory. Pen drive, flash drive, pen drive, flash drive, or CD, DVD, whatever you use it now, Blu-ray or maybe a hard disk, everything I'm saying, etc. for that. All that is called secondary memory. And then towards the end of this, we have something called as virtual memory. Now this virtual memory is not a real memory. Okay, virtual memory is not a real memory. It's only a portion of the secondary memory which is carved out by the operating system. So secondary memory has a lot of space. So what our operating system does is it cuts off a little bit of the secondary memory and keeps it aside as virtual memory. When RAM runs low on space, that is too many applications are running on RAM, then there is a small activity that takes place called as moving data from RAM to this virtual memory, where there is a file called a paging file. Okay. Anyways, I hope you understood I will explain that piece that I was explaining in detail, the virtual memory thing. But you can take a screenshot of this, or if you have already following and writing the notes here, you can obviously make note of all this. This is the entire breakup of hardware in clear detail. Then going by this, I just want you to understand a little more about this virtual memory thing. So what is virtual memory? A small example will help in this case. Let's say we have only a 4 GB RAM. Okay, a 4 GB RAM. That's for your understanding. Let's say this is the portion of the working part of the RAM. Now application 1, 2, 3, 4, 5, 6. You have opened so many applications at the same time because right now it permits multitasking. Not a problem. Then there is some secondary memory here. Secondary memory is there, let's say, on the hard disk. Now this one's a huge space, lot of space is there. Let's say this is a 500 GB hard disk. Now what the operating system does is to carve out a portion. So this portion is carved out, it's not available, and this portion, whatever is carved out, this is labeled as virtual memory. This is labeled as virtual memory. A portion of the secondary memory is carved out and this is named as virtual memory. Now listen carefully what's happening here. Here in this virtual memory, we have something called as a paging file. Now actually what happens is, when you open up the 7th program, the RAM is almost full, right? It's always full. Now if you continue to run this, the RAM is about to crash. That is, it's going to start not responding and your system will again go and hang. So to avoid this, the least used, let's say program number 2, program number 4 are open but they are not used. So immediately such program number 2, 4, 5 which are less used or unused, less used or maybe temporarily unused, you know what is being done? They be moved to the paging file so that it frees up the RAM. Now 2, 4, 5 when they go, there are only 1, 3, 6, 3 programs running. Enough place is there for the 7th one to work on the RAM. Computer doesn't slow down, computer doesn't hang. So that is exactly how virtual memory helps us. When RAM runs low on space, RAM is low on space, temporarily all those unused or less priority applications are moved to a paging file, and then program number 7 is done. And when program number 2 has to run back the paging file, it comes back from the paging file to the RAM. So moving up and down from and to the paging file will free up the RAM space, and that's how the virtual memory helps. So I hope you are getting the understanding of what this entire story is. Guys, we are dealing information system components, wherein we have 6 components to discuss people in detail. This is what you see right now here. This is the only part of people. Then we spoke about hardware, and hardware, this entire thing that you see is called the hardware. And now we will move on to discussing what is called as software. So after discussing what virtual memory is all, right? Let's move on. Part 3, we are discussing what is called as software. And in this we have 2 types of software. Let me first discuss about operating system. Operating system also has another name, system software. System software or operating system both have the same meaning, and generally they do 2 things. Okay, so they are supposed to do 2 things. One, they provide a platform for the user and the hardware to communicate. If there is hardware and there is no system software, that entire hardware is nothing but a worthless piece of plastic or silicon, useless. So to give life to the hardware and make the hardware function, the operating system, it is the one that makes all the hardware perform. So performing hardware functions, performing all the hardware functions, and provide platform for application software. So again, you know, right, application software is the other type of software, application software, because application software is something that is used to satisfy specific user needs. They are not meant for running the computer, because running the computer is taken care by the operating system. So if somebody asks you in simple terms, what does the operating system do? Running the computer is the job of the operating system, while application software that satisfies specific user needs. That's what it does, satisfying specific user needs. But when it comes to this, it performs all the hardware functions and provides a platform for the application software. It does called running the computer. So if you ask, another important part of this topic is the functions of operating system. What are the functions of the operating system? What are the functions? An important short answer question, guys. 8 functions are there, right? As I said, 1, performing hardware functions, that every hardware works only because of the operating system. The keyboard does the job of a keyboard, and mouse does the job of a mouse, and printer does the job of a printer only because system software is there. If that is not there, then you will not be able to use the actual benefit of the system. Then point number 2 is that it provides a user interface. Between user and the system. Otherwise, simply you can't let both of them talk. This is the ultimate part of it, user interface. Then the best thing about operating system is, once an operating system is written, the program, it can work on any hardware. Now like say Windows is the best example of an operating system that works on Dell laptops, HP laptops. You buy all the components locally and assemble them, then also they will work on it. And such a feature of the operating system is called hardware independence. independence. It is not dependent on any type of a hardware. It works on any type of a hardware. Then we have points 4, 5 and 6, which are three things related to management. What will the operating system manage? It manages memory. Memory management is nothing but what you saw here. This entire activity is called memory management, that carving out a portion, okay, from the, when main memory runs low, carving out a portion and making virtual memory available. That is the function of the operating system. That is called memory management. Then which task to do first, which task to do next, where multiple tasks can be done at the same time. All these are something called as task management. It's called as task management. Then we have one more management called as file management, neatly to store the files in one order. Now your file manager, I think most of you in your phones have an application called file manager, which is also a feature of the operating system. It does file management, which file is added where, it is stored in which folder, how is it stored, everything is recorded. Not only that, the operating system also provides logical security. Operating system also provides logical security. That means user ID and password facility is also provided by the operating system. And lastly, it helps you connect to the internet. So it also gives you networking facility. Networking facility. The networking facility is also provided by the operating system. So this is the best part about the operating system. System software, what is it all about? What are its two major functions and there are two major activities that it does, and the 8 functions of the operating system? This could be a very important question. Mark a star to this. And then let us move on to the fourth part of the operating system. Fourth part of the information system, that is called application software. Though software is a broad topic, you can split them into 3 and 4. Okay, people, hardware, system software, application software. Now we use so many types of application software to satisfy specific user needs, right? See, generally we use an application software to, probably like say you're using Photoshop to edit photos, a video editor and cutter joiner and PDF converter. Enough number of software. There's so many apps in your phone right now. They're all called application software that satisfy specific user needs. But therein we also need to understand various types of application softwares are there. Let us go with the types of software. Another star question, another short answer that's probably has an opportunity to come in the exam. The first type of application software is called an application suite. Is nothing but the best example for this is MS Office, where multiple small applications are bundled together. Multiple small applications are bundled together. For example, you have let's say Word, Excel, PowerPoint, Access, Outlook, all bundled into one software. So when multiple softwares are bundled into one software like that, that is only called as an application suite. Then you talk about the second one, you know, the ERPs. We already discussed about ERPs. They are enterprise-wide softwares, or simply they are called as enterprise softwares, which are applicable for one software, which bring the entire enterprise into consideration. The best example, SAP, Oracle, any ERP is the best example of an enterprise software. Then to control the infrastructure of the organization, probably to provide communication or probably to manage security. So the CCTV system softwares or the email, or probably the, nowadays, you know, in big buildings, big towers, 100 floors and all, their power management softwares, all those are called as enterprise infrastructure software. Enterprise infrastructure software. Then we have softwares which are used by accountants, auditors who basically work on information. Tally, computer aided audit tools, all those are called as information worker software. Information worker software. The best example for this is Tally. Okay, because he's working on some information. All computer aided audit tools, they all come under information worker software. And then we have next one called as content access softwares. content access softwares. Media players are the best example of content access. You want to play a song, you want to play a video, you want to access any content, you need a media player. So that's what is called as a content access software. Then we have educational softwares which are used for educational purposes, educational exam CDs, test CDs, all that educational softwares. And then the last one, which is called as media development software. What is it called? Media development softwares. This media development software has got nothing to do with media access software. Media players are what play a media, but what develop a media, like what music directors or video editors use. So this is all that media development software, wherein you can say a video editor, video editing, all those are called as media development software. Right now, these type of 7 different application software types are there. So many thousands of application softwares are available on the web. Some of them are called freeware because they're freely available on the internet. Open source softwares also they are called as, which are freely available. Some of them are paid, like you can check out your Play Store or iOS store, the iStore or Play Store, to download so many applications, to buy so many applications. So all that gives life to the working of a system. So 2 softwares, one is called the system software and the second one is called application software, is undoubtedly essential. So at this point you can take a screenshot of this also, we can take into consideration. So what are we dealing here? We're dealing people, hardware, and in software we discuss system software and application software, point number 4. Point number 5 is a very simple topic. It's called networks. Networks and networks are of 2 types. Here only I can write on that. Connection oriented networks. Connection oriented networks and connectionless networks, where everything is connected before in hand completely, like a telecommunication setup. From one end to the other end already cables are laid down, already it is connected, everything is taken care of, and that is called as a connection oriented network. But when things are not done like that, wherein they are called as connectionless network, you establish a point to point connection from one place to the other while communication is happening, that is what is called as connectionless networks. And in network we have topics like routing, right? Okay, I will take you through those words now, some of those. So I hope everybody has understood who are people, 2 what is hardware, 3 what is software, and now let us talk about a quick insight on the term networks. Networks are a very important part of today's communication, because if networks are not there, you will not be able to communicate. Networks are nothing but network is nothing but a group of computers. Network is a group of computers connected, and you have connections, different types of connections like local area network, metropolitan area network, wide area network. All these are some of the terms that are used for citing a network. How wide is a network? Now if it's inter-country, one country to the other country, then it's called a wide area network. No sir, it works only in my city, it's called a metropolitan area network. Now what we have in our houses, when we are using connections for our buildings or one street to the other street, that's called a local area network. So basically how network is established is by connecting computers. The word internet is a short form of the word internetwork, means the whole world is interconnected. That's when it brings in interconnections. That's what is called internet. So when I'm saying I'm going to connect to the network through internet, that means you are networked to the whole world using a concept like www or something like that. World Wide Web, I mean. So going by that, there are 2 types of networks. One is called connection oriented networks, and then we have connection less networks. Connection oriented networks, as I said, where a connection is established before the commencement of communication. So before the commencement of communication, a full route is starting to end from here to here. If everything is laid down, it's called a connection oriented network. But where there is no predefined connection like that, no predefined connection, then wherein it is established from point to point when you travel, that is called connectionless. This is like more like postal networks. The best example of connectionless networks are postal, because first you post it in your post box, from there it goes to the local post office, from there it goes to the head post office, from there it goes to the other city's head post office, from there to that city's local post office, and then to the person whom you sent. So at every point it is establishing the next destination where to go and go. That is why this is called as connectionless, and this is absolutely starting to end. There is a fully defined connection. Telecommunication is a very good example, because first telecom, everything is connected, and then connections or connection lines are established. So that's how connection oriented networks and connectionless networks work. Then we have a few terms here that are called as terminology. Now wherein I'm going to revise a few important terminology for you. First, which is called bandwidth. Bandwidth is nothing but the amount of data that can be transferred. Amount of data that can be transferred. Amount of data that can be transferred, that is what is called bandwidth. The 5 Mbps, 10 Mbps, 100 Mbps, that's what is called bandwidth. Then we talk about the next word, which is called as routing. Routing, we have devices called routers. Routing is nothing but how the data moves from one place to the other, how they take care of in short you can say deciding how to communicate. Deciding how to communicate, which is the shortest route, how will I reach the destination quickly. So all these are taken care by the routing function. Routing is a function performed by the networks in sending the data to the right person. Then we have something called as resilience. This is a very important word, because resilience is a feature in clouds, resilience is a feature in grid and all that. Is nothing but the ability of a network, to recover, from any crash. If there is ability of any network to recover from crash, so there is any network crash without disturbing the end user, if it's getting back, that is only called as resilience. And like say for example in cloud there is resilience. For example, there's a server that got damaged in Google offices, and I have to access my Gmail account. My Gmail data is there in that particular server. Now they will not call me obviously and tell that today your server is not working, because the server in which your data is stored is next person sitting next to me is able to use Gmail. I am not able to use. How can that be possible? So what immediately Google people do is to convert all that data in that device, move it to another device which is fully functional, and they will repair that device. Now here sitting at this end, first of all I don't know in which device my data is stored. Point number 2 is that whenever I am accessing Google, I am able to get my data whatever I want. This feature is called as resilience. Irrespective of any kind of crash, the ability of the network to recover from such crashes, that's what is called as resilience. And one more word I want you to remember here is called contention. Contention is nothing but multiple people, or rather than saying people, I'd say multiple. On network we call them users or peers. So I'll say multiple users trying to access the same network. All of us are trying to attack the Amazon server or Flipkart server. Like say Flipkart big billion day sale, all of them attacking Flipkart server. This network contention. Too many people trying to access the same network at same time. That's the point. Too many people are on the day of results. Why should I take other examples? On the day of results, everybody is onto the ICA's website. That's why sometimes it doesn't work. On that point of time, you see 404 page not found. Page is not found. No, temporarily it's not available, because there are too many people requesting that page, and server is like, no boss, I can't respond to everybody. So which is exactly why we have some activities called as traffic monitoring, traffic control, contention control. The word contention means multiple people trying to access the same network at same time. That's when network contention occurs. If too many people are trying to attack it, it slows down the whole network, right? So this is an exact picture of what networks are. So I think this session is going pretty fine in terms of understanding all the components of the information system. We have one last very important component called data. So before I discuss that, let just once again quickly, I know I'm doing this so many times, but I want you to understand the importance of this, because there are definite questions from this topic. So even if one day before the exam you listen to this session and you are equipped with the respective need for whatever it is, you can go ahead and deal with the things properly. So this is the overall picture of information systems. This is the third time I'm doing this, I know, but it's of some help to you. That's why I'm doing this. 1 is about people, 2 is about hardware, 3 system software, 4 we've discussed about the application software and types, and 5 we discussed networks. Hope this picture is coming clear. The reason I'm repeating it is so that this framework right now you see on the screen, that sits in your head, and then number 6 is all about data, where we are going there to the last part of our discussion. So this is the breakup of hardware, this is the breakup of software and application software, this is the whole concept of networks, and the last concept right here is data. You know what data is, right? Raw facts and figures, raw facts and figures, which are, somebody can call them as meaningless. They're not actually meaningless, that meaningless, or you can say without a context. The data is something that is without a context. Absolutely, whatever is there is making no sense to who exactly designed it, what is the access of that data. So raw facts and figures which are absolute no meaning, that's what is called as data. Then when you put this data into one particular place, or it is located in one particular area, that's what makes it a database. A database is a collection of all the data in one place. Okay, collection of data. You can simply write one more definition for this. It's an organized collection of related information. All related information, if you are putting it in one place, that is only called as a database. All related information, if you are putting it in one place, that is only called as database. Few small databases put together, make what is called as data marts. What does it make up? Data marts. A bunch of data marts put together, few data marts put together, makes it a data warehouse. In the second chapter, we already spoke about doing data analytics. Now this data warehouse is nothing but a repository of all information. It is so huge, right? It is thoroughly so huge. So that's why it's a repository of all the information located in one place. To construct a data warehouse, you have two approaches. What are the two approaches? One is called a top-down approach, and the other one is called a bottom-up approach. You know what you do in a bottom-up approach? First, you start creating a database, convert it into data marts, and from data marts, so bottom, like a brick by brick approach. Set up one brick, one more brick, and finally make the big wall. So that is what is the approach which is called as bottom-up. Start with 0 and then create a database, then make it data mart, and then slowly go on one after the other. That's what we do in terms of what is called as a bottom-up approach. In top-down approach, it is the opposite. First, we construct the entire data warehouse, break down the data warehouse into some data marts. From these data marts, you make much smaller databases. This is all to do with the top-down approach. In bottom-up approach, first we make these, then convert them into few smaller data marts, and then this entire data mart is converted into one big data warehouse. So this, from brick to brick to brick, this is making the entire data warehouse is top down approach. Breaking down the entire this one into this direction. Full data warehouse broken down to data marts, and then it's made into data bases. This is called a top down approach where the full is broken. Where first data bases are created, bases make marts and marts make a data warehouse. That's what is called a bottom up approach. Bottom up, you can also call it as a brick by brick setting up a big, the entire wall is constructed and then parts are divided. That is called a top down approach. So this is what is a basic understanding of what is data, database, data mart, data warehouse, and two approaches. And then in database we have what are called as softwares. Software to manage the database is called as database management system or DBMS. Using DBMS, what all can you do? Using the DBMS, you can do adding new files, deleting existing files, adding, deleting, inserting data into files. Adding a completely new file is this, but when you say inserting data, it means you're doing it into a particular file. Inserting data, modifying data, and retrieving. Retrieving is to get back the data what is stored. So all these are actions performed using a DBMS. DBMS is a software that will help you to manage the various kinds of databases, and the database can be added. You can add new files to the database, you can delete existing files from the database, insert data, modify the data, and retrieve the data whenever you get. And then database, inside the database the information is arranged in a particular manner. The way data is arranged inside the database, that is called as database models. Database model. How is data arranged inside the database? That is what is called as a database model. I will discuss this database model in detail because 4 types of database are there. Meanwhile, you should know the database hierarchy. Okay, so we will discuss that also before we close this. So I hope right now what you see on screen sums up the understanding of the basic in data. What is data? Database. A DBMS is a software that helps you do all these 5 functions. And what's a data warehouse? And the 2 approaches in making a data warehouse. Going further, I want you to first understand the data hierarchy. Okay, each individual unit in a data is called as a character. Each individual unit, like every bits of data is called as character. Every bit. Bunch of characters make something called as fields. Fields together make records. Fields together make what? Records. And records together make files. And a bunch of files together make a database. That's what this story is all about. So this is called as data storage hierarchy. Data hierarchy. When you say what is data hierarchy, the lowest part of the data that you can pick up is called as a bit. Each binary digit is called a bit, right? So that's what it is all about. It is called as a character. So every bit, now you know that 8 bits make 1 byte, right? So every bit is called a character. Letters, numbers, spaces, punctuation marks, everything turn out to be character. Bunch of characters make fields. Fields together make records. Records together make files. And files together make a database. This is the data storage hierarchy or the data hierarchy. Then let's talk about the point that I told you in the previous one. Database models. Database model. As of now, there are 4 models. Okay, we'll discuss each of them in clear detail. First one is called as, again, hierarchical model, network database model, relational database model, and object oriented database model. Object oriented. Okay, let me go with each one of this. I'm going to explain these models carefully. Most people I've seen having trouble with this, so just concentrate. It's a very easy part. Let's start the hierarchical model. As the name goes by, hierarchical model follows an inverted tree pattern. Inverted tree pattern. What is this inverted tree pattern? You know, like tree starts with a root and grows up with branches. So inverted tree, the root is on the top right here. This is called the root, or it's called the root record. Root record. Now you already know that, you know, end points in network terminology, normally the end points are called as nodes. Nodes are nothing but end points which are connected. So this is called the root node or root record. From this we have, let's say for example, here we have 3 branches, and further to this we have from here another 2 branches. From here we have another 2 branches. This is stretched into 3 branches, and this probably has another branch, that has another 2 branches. Like this it goes with a hierarchy flow. Now this starting record is called the root record, followed up by the other records. And the entire thing in hierarchical model works like a parent-child relationship. This is called the parent record, while this is called the child record. Now also this child record becomes a parent record for these child records. So the entire thing goes by 1 to 1 and 1 to many relationship. 1 to 1 and 1 to many. These are the relationships that are established in a hierarchical model. It's a very simple model. It follows an inverted tree pattern and starts with a root record, and then it goes up via expanding them into branches, and the branches are going on extending. But look at the drawback of this model. The more you have data, the more content you have, the greater is the number of branches, and then coordination will be a problem. And one more thing, if you look at here, this branch is not connected to this. What if these two are related? So that is not there, which is why this model is not a very sought after model, and it's used only when data is small. But one more important thing is there. When you need data redundancy, that means repetitive connections and lot of data to be connected and all be at one place. When you have small data, you can again go for what is called as a network model. You know, in network model, 1 to 1, 1 to many, many to 1, many to many, all are possible. Like say for example, we have actually, this is termed as non-structured, because there is no structure. Anything can be connected to any end. Something can be connected, something need not be connected. So I'll give you a simple example to see for. So we have, let's say, 5 data endpoints, where these are all the units where data is there. 1 to 2, 1 to 3, 1 to 4, 1 to 5, 2 to 3, 2 to 4, and then 2 to 5, 3 to 4, 3 to 5, and then 4 to 5. This is a fully interconnected. Everything can be connected to anything. Sir, I don't want, 1 to be connected to 5. You can obviously erase this part. But having said that, like I said, that depends on how the interconnectivity needs to be there. But all of it, 1 to 1, 1 to many, many to 1, and many to many, all 4 relations are possible. It's a fully interconnected. But just in case, if you have lot of data, again this is not a great model, because when the more data is, the more the number of interconnections. See, for 5 points itself it is so clumsy. Think of 6, think of 8. The more it's going to be having information, the more it's only going to get clumsier and difficult. So which is why, to avoid that, we will obviously go for hierarchical model if the data is simple. But if data is not simple and it needs much of redundancy, then we can go for network model also. But in both cases, 1 and 2, you need to keep the data content small. If the data is huge, then going by using hierarchical and network models do not serve the purpose much. So then what should we do? Go for model number 3. which is called as relational database. Relational database. This is a very, very important part. I want you to closely understand this example, then things become very easy for understanding the relational database. To understand relational database, we need to know three terms. Term number one is called relation. Then the next term is called attributes. And the next term is called as domain. Now let's first understand what are these three words. Relation. Relation is nothing but a table with rows and columns. A table with rows and columns. That's what is called as a relation. Attributes. When you have rows and columns, and some of these columns, when they are named columns, they are called as attributes. Named columns are called as attributes. And domain is nothing but set of values that can be given, or that it can take, set of values that these attributes can take, that can be given as attributes. That is what is called as a domain. Domain is a set of everything. So three words, you know, right? What is a relation, what's an attribute, and what's a domain. Let me tell you how this works. They all work in the form of tables. Let's say first we'll take a table wherein we have a few aspects. Let's say this table belongs to sports. Okay, sports. And in sports I have cricket, football, volleyball, tennis, and maybe I'm taking even other balls, softball, okay, pole vault, long jump, just a few games, whatever. From there, now this is the entire thing. You can see that this contains about sports. Okay, then let me have another box which talks about a few more things, like for example I'm talking about cricket. Then in cricket I have test cricket, ODI cricket, then we have T20 cricket. Okay, then we'll make another box with test cricket, which is the regular test cricket, day and night test cricket. Then we have a box, let's say for T20, we have an international T20. Then we have leagues, T20 leagues. Then we have, let's say, another box wherein you have only T20 leagues, wherein you have IPL, Big Bash. Let's say this is how data is arranged. Now, what is the point in arranging the data like this? Now, every box has something that represents that particular box. This box deals with cricket, this one deals with test, this one deals with T20, such things which identify uniquely. Anything that helps you identify the table uniquely. Such a thing is called as a primary key. What is it called as? Primary key. Now if you see, since data is organized like this, the beautiful part of this is, like say sports is the primary key that represents this box. Cricket from here is connected to this. This represents a relation. Test cricket is connected from here to here. Then T20 is connected from here to here. T20 leagues are connected from here to here. And as many relational database boxes you can make, those many boxes you can make in the form of tables and keep the data. Sir, why you wrote cricket first? Can't you write football first? I can write anything anywhere. Okay, I can write in the first box here, I can write football, here I can write cricket, or I can write here. But two things to be kept in mind here. One, the ordering of these are not really problem. So let me say three rules are very important. Rules. To create a relationship database, rule number one, ordering is immaterial. Ordering is immaterial. Let it be in any place. Doesn't make any sense. The ordering is totally immaterial. Then point number two. Okay. Now you have cricket in this box, right? There can't be one more cricket in this, because if you are connecting here to here, then next time there will be confusion. Is it from here to here or here to here? So which is why we need to have a clear understanding, and there should be only one record in one box. So rule number two, there can't be an identical record in a table. There can't be an identical record in the table. Understood? See here, if I have one more T20 somewhere, which box will I connect? This T20 box should be connected to this or something else. Now if another box has T20, that's fine. From there also I'll bring and connect it here. But same table should not have two boxes with identical records. And 3, each record, whatever is having, each record contain a single value, for its attributes. Why single value? Because you can't write in the same box cricket and football, cricket and politics. You can't write like that. So that's why single value. 3 things. 1, ordering is immaterial. 2, there can't be an identical record, and each record should contain only a single value. And the most important thing is every table is identified using what is called as a primary key. I hope everybody understood this concept, because lot of people, their problem is they never try to make an attempt to understand what this is, either blindly by heart or ignore it. So please, once again, I'm taking a minute to just remind you about 3 words: relation, attributes and domain. And then we have a table with rows and columns is called, keep this example in mind, this is very easy. Have a table with rows and columns, and respective tables will have attributes. Attributes will link to the other boxes, that is only called as relation. Here also various boxes are linked to each other, and that's how a relational database is formed, with 3 rules to be kept in mind. Every relational table is identified by unique identifier called as the primary key. So if you have any more doubts, you can read the entire content once again after listening to this. I think it will all be clear after that. So the last one, where we are going by the last data model, it's called Object Oriented Database Management System, or OODBMS. So what is the concept of OODBMS? The entire world is modeled into objects. Entire world is modeled into objects. So you are one object, I am one object, everything is an object. Let's say this is one object, another object, this is object 2, then we have another object 4, then we have another object 5, or anything like there are many more objects. So what we do is, from one object to the other, from this object to the other, this to this, maybe this to this, this to this, relations are established. Again, you understand one point, that OODBMS is also a relational database, RDBMS, but used for complex data like image, audio or video. So if complex data like image, audio and video are there, everything is organized in the form of objects. So you are one object, I am one object, that image will be one object. So if somebody tries to know about me, I and the object like my image are connected, I and a YouTube video are connected, I and something else is connected. So YouTube's database is an object oriented database, Google Images is an object oriented database. Basically what you do is, they image, audio, video, all these websites which have songs, so neatly organized and stored so that you can retrieve whichever song you want. They're all part of the object oriented database, which follows the same concept of relational database. Everything is arranged in tables, but from one object to the other there is a linkage established. So if somebody asks you what object oriented database is used for, it's used to store image, audio, video, a little more complex content than text. That's what is called as an object oriented database. And then those are the 4 data models: hierarchical model, network model, relationship model and a object oriented database model. So these are the different points involved in discussions of this concept called data. We discussed so much about it. It's an extensive topic, data. So data, database, from database to data marts to data warehouses, 2 types of approaches. And then a software to access this is called the DBMS. And then the 4 data models. So I hope this session has been informative in communicating all the points and components relating to the information system. So there on your screen is the 6 components of information systems which are explained in clear detail. So if you have done one round of revision and then come here, this session would have been of great help. Or if you've come till here, that is listening to this right now at the end of this session, I hope it has been informative. So what I want you to do is to go back to this topic and read it at length once again, and then use this video for a revision purpose, right? So if you have anything to share, you can always do that with us through the comments, because I would like to know from you what exactly are you looking out for in these kind of videos. So if there is anything that you want us to know, you please do that, and feedback is always good, right? And I will see you in my next revision video, where I will be discussing about second part of this chapter, that is called as information system controls. We'll look down the breakdown of controls and what those controls are and how they will be discussed in detail. So I will take you through that in the second part of this chapter, and finally we will discuss about anything left over in controls plus all the audit tools in part 3. This is a chapter which is of great length, but nothing to worry, that's why we have split it into parts and we're doing. Hopefully everything is going well. Keep up your preparation levels. I will see you soon in my next video. Thank you.